So I want to really emphasize that on this first part, the instructions say factor. It does not say solve. It is not an equation. All right? Factoring is a reverse distributive property. And the first thing you should always try to do is to look at all of your terms and see what's in common and pull out what we call the GCF. So what could we pull out on number 1? 2. Right? Now, if you jumped right into it and you started doing the steps, step 1, A times C, you get 24. Think of the multiples of 24. See, you're going to be doing so much more work, because if you just take a couple of seconds and think, oh, there's a 2 in common in all these 3 terms, I want to pull out that 2, what would be left on the inside? In other words, 2 times what takes you back to the 2b squared? B squared. And then what's the next term? Plus what? 5b. And the last term, what would it be? Plus 6. Okay, now if you just look at the blue, that is a quadratic trinomial, and the a value is no longer 2, it's 1. Which means you could now do this setup and put b and b. Of course, we're ignoring the outside 2 that we just pulled out. But now we could be thinking, what times what is 6? That if you add it together is 5. 2 and 3. And now let's not forget about the outside value 5, which is just 2 times, so just put that down. And this is the completely factored form. That's it, we're done. That's your answer. Now, I do want to mention, if this would have been an equation, like let's say, let me do it in purple. Let's say we had an equals 0 over here. Then you'd have an equals 0 right here. And then I would divide by 2 to cancel it, and divide by 2. And then I'd have b plus 2 times b plus 3 equals 0, if we had the equal 0, but we know we don't have an equal 0, if it were an equation. And then I would have to continue solving by doing b plus 2 equals 0, and then I'd get an answer of b equals negative 2, and then I'd have to do b plus 3 equals 0, I'd get an answer negative 3. But obviously this is not an equation, so we're not going to be doing that. On the second half of this worksheet, we do have equations, and on those we will have to factor and then split and solve. On this one, it's just saying factor, so that's it. Again, this is still not an equation. Number 17 is not an equation. We're just factoring. So always, what do you start with always? What's the first thing you're supposed to always try to do? Should I multiply 18 times 18? No, that's not good. What should I do first? Greatest common factor. Now, sometimes there is no greatest common factor, so yeah, you're going to have to do a times c as step 1. But in this case, there is a common factor. What is the greatest common factor? Anybody? 3. Okay, so let's pull out a 3. And if we pull out a 3, what's going to be left over? 6h squared plus 5h minus 6. Okay, so what does that do? Now we have a quadratic trinomial that at least have easier numbers than the above numbers 18, 15, and 18. Now we're going to be dealing with 6, 5, and negative 6. It's a little easier. Okay, so now let's go through the process. Step 1, multiply a times c. What is a times c? In this case, inside the parentheses, ignoring the 3 that I just pulled out. Negative 36. Because we have a positive 6 times a negative 6 is negative 36. Step 2 is to make a list of numbers that give you negative 36 when you multiply, but when you combine, you ultimately want a plus 5. So let me make a list of numbers of negative 36. Negative 1 times 36. That gives you negative 36. Negative 2 times 18, that gives you negative 36. Negative 3 times 12, that gets you negative 36. Negative 4 times 9 gets you negative 36. And negative 6 times 6 also gives you negative 36. Out of all those possible pairs of numbers, which combine, which means, add, together to give you 5? Negative 4 and 9. Okay, so step 3 is to rewrite our trinomial. And of course we're only focusing in on the black trinomial here. We're ignoring the outside 3 that I factored out at the beginning. So we're going to rewrite this trinomial, but replacing the middle value 5 to be these two numbers, negative 4 and positive 9. So this 5h, I'm going to change it to a negative 4h and a plus 9h. So there it is, 6h squared is right there. This 5h, I rewrote it with two blue terms. I got that from the pair of numbers on step 2. So 5h became negative 4h plus 9h. Actually, if I add negative 4h plus 9h, that would give us the original 5h. Notice that I left some space between them. I left that space strategically because I know my next step is to factor by grouping. Okay, so let me zoom in or focus in just on this part. In the first group, what could I pull out? A 2 and an h. Okay, so let's pull out a 2h. And what would I have left on the inside? 3h minus 2. Excellent. Okay, now in the second group, over here, what could I pull out? Let me put some parentheses here. What could I pull out of both of those? A 3. And if I pull out, notice that we're saying 3, but let's put a plus for positive 3. We're pulling out a positive 3. And of course, we will have a 3h minus 2 also. And then this is where you take a step back and realize what's in common in my first group and my second group. It's the binomial 3h minus 2. So let me take a step back and let me pull out that binomial 3h minus 2 and put it out here in the front. So of course, if I pull out the 3h minus 2, the 2h and the plus 3 will be left over. Again, the 2h and the plus 3 will be left over. I did exaggerate the parentheses right here. I left the blank spot and blank spot so you could actually see it missing. I pulled it out. It's not there no more. You want to write it in the appropriate size. So the appropriate size will be, this is the factored form with the appropriate size. Let's not forget of the original value of 3. You guys remember at the very start we pulled out the GCF of 3 from all these terms and we wrote it out here in red? We need to also slap that onto our answer, our completely factored form answer. So there's your final factored form of number 17. Let's actually jump to the second page. I left a lot of space so you guys could work it out. I want to jump to the second page where we're solving equations. I'm looking at number 20. Number 20 is interesting because the equation is not set equal to 0. So of course that's the first thing you want to do. You want to set it equal to 0. So what do I do to set it equal to 0? Subtract 2, that's right. Cancels. Subtract 2. You can't really subtract 2 from a letter, so we're just going to rewrite it. There it is, 15n squared minus n minus 2 equals 0. Could I pull out a GCF from this thing? Is there something in common in all three terms? No, right? Nothing in common. Okay, so let's start jumping to our steps. Step 1 is to multiply a times c. What is a times c? A times c is negative 30. And it's very important that you get the right sign, okay? Because your list is going to be based on that number with the correct sign. So your list is going to be all the different ways of getting negative 30. So there's my list. If you struggle with your multiplication tables, go ahead and get that calculator and just think about, okay, 30, 1 times 30, what's half of 30? It's 15. 2 times 15, 3 times 10 gives you 30, 5 times 6 gives you 30. All of them with negatives in the first one. So which pair of numbers combines together to give you the middle value, which happens to be the negative 1? Which pair of numbers? Negative 5 and 6, okay, that does give us a positive 1, right? If you add negative 5 plus 6, it'll give you a positive 1, and if you notice, the b value is negative 1. So you have the right numbers, you just have the wrong signs, so it's really going to be a positive 5 and a negative 6. Positive 5 and negative 6. So once we have those two pair of numbers, we're going to rewrite the whole original quadratic equation, but instead of the middle value negative 1, we're going to replace it with these two numbers. So I want to write this whole thing over, but instead of one single middle term, I'm going to write both of these as my middle term, and of course with n on each of them. So there it is. I have my 15n squared. My negative 1n I'm going to rewrite it as plus 5n minus 6n. That really does give me a negative 1n after all. Notice that I left some space between it because I know I'm going to factor by grouping. Not only that, the equals 0 at the very end is right there. I'm just not showing it right now. So let's factor by grouping. In the first group, what could I pull out? 5n. So let's pull out a 5n. What would be left if I pull out a 5n? 3n plus 1. Excellent. In the second group, what could I pull out? Negative 2. Perfect. And if I do pull out that negative 2, what's going to be left? 3n plus 1. Perfect. Now this is great because the 3n plus 1s are both the same. Let's say you would have ended up with the 3n plus 1 and over here you end up with the 3n plus 2. Guess what? You can't continue, right? And that does happen a lot in Algebra 2. You would just say that it's not factorable, right? You can't factor it. Oh yeah, another word for not factorable is prime. But we'll get to that later. Right now we could pull out the 3n plus 1. Let's take both of these binomials and write it out here in the front. 3n plus 1 in the front. The 5n minus 2 is going to drop. Again, 3n plus 1 in the front. And 5n minus 2 left over on the inside. 5n minus 2 left over on the inside. Now remember, this is still an equation. We had the equal 0 part, so I still have the equal 0 part to it. And we're going to now use the zero product property to split them and solve. So I'm going to set it up 3n plus 1 equals 0. And I'm also going to set up the 5n minus 2 equals 0. So we're just going to solve this thing, minus 1 on both sides. You're going to have 3n equals negative 1. Final step would be to divide by 3, which means n equals negative 1/3. That is your answer, n equals negative 1/3. The other one, we're also going to add 2 to both sides, plus 2 here, plus 2 there. We're going to have a new equation that reads 5n equals 2. And my final step will be to divide by 5, giving us a final answer, n equals 2/5. N equals 2/5. Both of those answers are correct for this problem. So this is the hardest type of question that you're going to see on tomorrow's test. A lot of them are easier because you're going to be able to use a shortcut.